All right, so we're going to continue talking about sampling distribution models. I'm going to show you some applications of these models. We spent the last 2 days really taking a long time to do 2 examples. One where we were talking about proportions on Tuesday, and yesterday when we talked about means. So this first example is going to be about means again, but I'm going to show you a way that we are going to use these models to answer some questions with means and then with proportions. So we have the reported score distribution for the students who took the 2006 AP Stats exam. So take out your yellow calculator, click the button that says data. Click the button that says data, and in the first list, I want you to type in the scores, 5, 4, 3, 2, 1. That's in list 1. Then in list 2, you're already behind, so right? Then in list 2, you should type in these percentages, all right? And make sure you type like 0.126, 0.222, okay? Make sure you move the decimal over, all right? So that should be in list 2. So the scores in list 1, percentages in list 2. It doesn't have to be in that order, but I think it'll make more sense if you do list 1, list 2. No, probably not. Well, maybe as we get to the end, maybe. All right. Okay, so hopefully you have all of these in the first 2 columns. Now you're going to hit second data, which is really statistics, second data or stats, and we're going to do 1 variable statistics. So number 1 says 1 variable statistics, hit enter. All right, our data is in list 1, but you guys see where it says FRQ for frequency? All right, you want to scroll over and hit enter on list 2. Bless you, that's our frequency now. So you want L2 to be your frequency. And then hit calculate. Okay, so what is the mean for this data? Excellent, 2.859. So the average AP score for all students in 2006 was just under 3, 2.859. Okay, now let's look at the sigma. All right, if you scroll down in your calculator, you should see sigma, the standard deviation, is 1.324. Okay, any questions on how we found those 2 numbers? All right, that should hopefully have triggered something in your brain from before the break. We did that with our random variable distributions. Yes, Leslie?
For any future answers or questions like that, would you like for us to have a specific number of decimals placed?
I usually just tell students to go to 3 after the decimal. That's usually what I would do. Kind of like the way I view it is you have percentages already with decimals, so you want to go a little bit further than that. Okay? All right, I'm going to skip part B. All right, everyone, take a quick look at part B. Part B is something we already did yesterday, where you have to look at this sample of 40 stat students, and basically you're going to make assumptions, check conditions, and then show what the model would look like for repeated sampling of these 40 students. All right, I'm not going to do that. We've already done it. So I'm going to skip to C. All right, I'm going to skip to part C. We haven't done a question like part C. All right, so part C says we have an AP Stats teacher that has 63 students preparing to take this exam from 2006. All right, obviously not a random sample, but the teacher considers his students to be typical or a good representation of national students. All right, what's the likelihood that these students will achieve an average score of at least 3? All right, so what they're actually asking you to do is to find a z-score. Okay, now it's been a long time since we've done z-scores, but the way we do a z-score is we take a statistic, subtract it from a mean, an average, and divide by the standard deviation. So let me show you some symbols. So we're going to write y bar minus mu over the standard deviation of y bar. All right. I know it's been a few months. Y bar is the sample mean. All right, so the average score from these 63 students. All right, mu is the average score for the population, so all the students, which we just calculated. And then standard deviation for Y bar is a specific standard deviation for a sample size of this number of 63 students. That formula, which we used yesterday, is sigma over the square root of that sample size. All right. So what really tripped me up when I was learning this for the first time was you're going to have a different denominator every time you have a new sample size. Okay. So if your sample size changes, you've got a new standard deviation. Okay. All right. So let's plug in some numbers. What does it say about the number that we think these students are going to achieve on their AP score for this test? At least a 3. So the number I care about is 3. So I'm going to replace Y bar with 3. Okay? Now what about for the overall, all of the students that took this, what was the average? If you scrolled up, 2.859. So I'm going to replace mu with 2.859. All right? And if I'm using this formula over here, sigma over the square root of n for my denominator, I'm going to write my sigma 1.324 divided by the square root of 63. All right? So take out your yellow calculator to find that z-score. Remember, it can be helpful if you use the N over D button. Do you need to use that? You also, if you're not going to do it all in one fell swoop, make sure you wait till the very end to round. All right, your number will be different if you're rounding in the middle of your calculations. So hit enter. Hit enter. Now hit divided by. And then hit N over D. Okay, you see what I would do is I'd reset it. Okay, who's got a z-score? Okay, what'd you get?
845.
845?
Yes.
845, okay, confirm. Okay, yes, excellent, good job. Okay, now, probably haven't done this since like October, all right, but I have a z-score of 0.845. So I'm going to draw a curve, a normal model, and I want to shade where this is. Okay, so if the z-score is just shy of positive 1, where am I going to draw that line for 0.845? Like a little bit to the right of the middle. All right, so probably somewhere right here is z equals 0.845.
Because it's closer to 1.
Exactly, because you want to, I mean, it's just a sketch you're at, so even if you had it a little bit further right or left, that's fine. The key thing I'm looking for you're at is that it's not to the left of the middle. If it's to the left of the center, then it should be what at the beginning of this number?
Negative.
A negative, right? So it's not a negative, so it has to be to the right of it. All right, just a sketch. All right, now, what did it say in the problem about that 3 that this teacher wanted to use? At least, right? It says at least 3. So really, I'm calculating the probability that we get a z-score that's greater than 0.845. All right, so if I want to shade on my curve, what direction do I shade for at least? Greater than? To the right, very good. So I'm shading to the right. And once you get to this point, we are going to use the Chromebooks. Oh, no Chromebooks. Go get Chromebooks. Get the Chromebooks. I wonder if your phone could do it. Your phone might be able to do it. Take out your phone. Stop getting the Chromebooks. Take out your phone. Come on, guys. Jeez. Try your phone first. See if it works on the phone. And if it doesn't, I sent an email. All right, so check your school Gmail. And if you click that link, maybe it'll work on your phone. If it doesn't, then we'll get the Chromebooks. You're looking for the website. It looks like this. Does that pop up on your phone?
Yes.
It does. Okay. Are you able to type in where it says min? Yes? Great. So type in our min, which was 0.845. Very good. Where's my decimal? 0.845. Now, do you see where it says max? If we're shading to the right, what do we want to put there? Oh, shading to the right. You could put 5. 5 would work. You could put 3. 5's better. What am I going to put? Oh, you know what I'm going to put. I'm going to put infinity. A bunch of 9s. Right? Because I know that it looks like I stopped shading, but in theory, it's going on forever. Once you get past 3, like 5, the difference is very negligible. All right? But I would highly encourage you to use a very large number. Okay? Right? Did you use 5, David?
Yeah.
What did you get when you used 5? Did you get 0.199?
Yeah, but then like the ending.
But the numbers after it are different, right? Totally fine, right? Because we're rounding, it's not that big a deal. All right? So the probability of this shaded area happening in this scenario is 0.199. So if I were to write a sentence to this teacher, all right, what would I tell this teacher is the likelihood that his students are going to achieve an average score of 3 or higher? Right? I mean, if I'm writing like a quick note to this guy, writing an email or a G-chat, I'm not going to write 19.9%. What am I going to write? I'm going to say about 20%, right? This is just casual. Hey, Saul, you wanted me to check those numbers for you? About 20% chance. There you go. Have a great day. Good luck. Something like that. G-chat, right? Google Chat.
Yeah.
Google chatting. Messaging. Great. So there is about a 20% chance his students will score an average of 3 or higher. Okay, as you finish writing that, think what questions are coming up during that process. I'm trying to show you how we went from yesterday, which was like make the model, now we're using the model, right? I could have taken time to show you what the model would look like for a sample size of 63 students, right? I could have drawn that curve, we could have done the middle, the 3 above, 3 below, and you would have seen where that lined up, the 0.845, okay? But I'm trying to show you an application of these sampling distribution models. Okay. Let's do one with proportions. All right, so go to the next problem, flip it over to number 2. Okay, so number 2 says 34% of Americans say that math is the most important subject in school. Man, that seems low. Okay, now that's talking about all Americans. So it's a population. Do you remember what letter I'm going to use for that 34%? P. Very good. So I'm going to write P. Better P than that, Douglas. Come on. P equals 0.34. I'm saying that the population proportion for all Americans is 0.34, saying that math is the most important subject in school. All right. Now it's telling me that they take a sample of 400 Americans. What's the likelihood that they get a probability? So it's a sample proportion, so that's P hat, that's between those two percentages, 30 and 35. Okay? So we need to calculate 2 z-scores. So I'm going to do a z-score here and a z-score here. All right, now, the key thing I need your brain to understand is that even though this process is going to feel pretty much the same, are we dealing with means anymore? No, we're dealing with percentages. We're dealing with proportions. All right, so the notation that you write matters. So you're going to write P hat minus P over the standard deviation of P hat. Okay, you should be able to see some similarities, right? The y bar is a sample mean, and the p hat is a sample proportion. Okay, mu is the population mean, p is the population proportion. All right, same thing for the standard deviation down here. All right, your brain will start to see those patterns. So I'm going to do the same thing on the other side. Now, because we have proportions here, our formula for the denominator is going to be different. All right, the formula we used on Tuesday, it's been a couple of days, put it up here. The formula for the standard deviation of p hat is the square root of pq over n. All right, and just a reminder again, you don't ever need to memorize that. I will always give you that formula. Okay, everybody good? Ready to plug in the numbers? Okay, so I'm going to do the low one on this side, right? The 0.3. That's going to replace p hat over here, 0.3, minus my population proportion of 0.34 divided by, I'm going to plug these numbers in, the square root of 0.34. Okay, what's the, if 0.34, so 34% of Americans say that math is the most important subject, how many are saying it's not the most important subject? 0.66. All right, if you're confused how we got that, you subtract the 0.34 from 1. Okay? Yes, Charlize. This one, it's because it said, what's the likelihood that it's between 30% and 35%? So basically, I'm getting a Z-score for 30% and then a Z-score for 35%. All right, I'm going to figure out what's going on in between. Okay, divided by the sample size of 400 Americans. So that's going to be a number. All right, that's going to be a Z-score. Let's do the same thing for the other side. Okay, our p hat on this side, the greater one is 0.35 minus the same population proportion over the square root 0.34 times 0.66 over 400. Okay? So then once I have the setup written out, my work has been shown, I'm ready to go to the calculator to find these Z-scores. Good question. So Charlize, your brain is like, whoa, it's a negative. We had the one before wasn't. Does that make sense that it's a negative?
Yes.
How do you know it's a negative, David? Because the key thing I always look at, Charlize, is look at the numerator. The numerator, that p hat is below the population proportion. So yes, this one's going to be negative. And if you look on the flip side, this one is greater than that one, so it'll be positive. Okay, Charlize, since you got a negative, what did you get? 1.665. Anyone else? 1.688. Oh, I got you. The 0.35 here should be 0.34. All right. One thing I like to tell students, especially as we move in the next month, is do you guys see the population proportion of 0.34? Do you see how you see that again in the denominator? That will always be true. Okay? So those numbers will always be a match every time. Okay, so we're going with negative 1 point. Does it round to 689? Thank you, Leslie. Okay. And what about the positive? Anybody have the positive one? I heard Catherine say 0.422. Yeah, she said positive. We're doing this one positive? Yeah. This one's a negative over here. 0.422? Wences concurs. Okay, so as you're getting to this point where you have your z-scores, okay, we're trying to find the likelihood that it's going to be between these two numbers. So when I draw my curve, right, okay, I'm going to sketch negative 1.689, 0.422, And the phrase here is between as opposed to at least on the previous model. So we're going to shade in between them. Bless you. There we go. Yes. I don't. I'm sketching it. Key thing is the one that's negative. Negative 1.689 is close to negative 2, which is getting pretty far out there. 0.422 is just barely past the middle, right? The middle is 0. So if the middle is 0, I went just a little bit to the right. But again, it's just a sketch. I'm not that worried about it. Okay? Okay, so if we go back to your cell phones, that same link, all right, the same link from before, the minimum value was negative 1.689, I believe. Yes, and the maximum value then, shouldn't have written all those 9s, Douglas. That's what I get, was 0.422. All right, and Edgar, if you wanted, your question was, how do you know where like the sketch is? I mean, right, if you're doing this is your job, you could literally just, there's a thing called a snipping tool, you just snip it and paste it wherever you want it. Okay? By the way, if you've never heard of the snipping tool, have you guys heard of the snipping tool? Okay, good, because if you haven't, it'll change your life. See, I'm not even joking. Change your life. You've never heard of the snipping tool? Oh man, next time you're on a computer, just search snipping tool and just enjoy. Okay, so the answer we're going to put here is 0.618. 0.618 is that likelihood. So let me show you the notation here that I would have put. The probability that our z-score is less than 0.422 but greater than negative 1.689 is equal to 0.618. Right? That is what I would call the answer. All right, because this is a multiple choice question, you can see that the answer is D for Douglas and David. Good thing.